Welcome to the next video in the group theory series. In this video, we will make official the definition of a group. You can see here a preview of everything to come. Okay. Let G and H be any sets. This asterisk an operation from G to H. If these satisfy closure, associativity, identity, and inverses, then the pair G asterisk is called a group. So let's talk about what some of these words mean, although we've already been using them, but let's talk about them in a little bit more formality. So closed means that H, the range of the operation, is a subset of G. That is to say, if you put any two of them together, this value of the operation being an element of the range should then be in G. Before moving on, a note about notation. The notation that we use here is evocative of multiplication. When a group is additive, like the integers or even m by n matrices under addition with integer coordinates, for instance, although others are possible as well, we will write with the plus symbol between the elements. For multiplicative groups, like for instance, the general linear group on just about any number set, we will in fact use concatenation. That is to say, drop the multiplication symbol entirely, just like with regular multiplication. So if A and B are any two invertible matrices, effectively, with coordinates in this number set X, then we will write their product just with A concatenated next to B. An abstract group is one for which we haven't specified anything, or at least we haven't specified very much about it. I suspect that it is out of laziness that for abstract groups too, we default to concatenation to write the product. So while G asterisk H is the official correct notation, it is understood that GH means G asterisk H. Because this is evocative of multiplication notation, we therefore, by default, use multiplication notation consistently for abstract groups. This means that we write 1 for the identity element of an abstract group. That is to say, 1 is what we will write as the element of G, which is the identity element, even though the number 1 may not be in G. Likewise, if G is a group element, then we write its inverse in the notation of a multiplicative inverse, that is to say, with a superscript of -1. Let me emphasize how good laziness is. Mathematicians are experts at the good use of laziness in writing, computing, and in many other ways. This allows us to only exert serious effort on the interesting stuff. Note that when a group is additive, we write the operation identity and inverses consistent with additive notation. So the operation is written with a plus sign. The identity is the symbol 0. Again, it doesn't have to actually be the number 0. It could be a matrix 0. It could be a lot of other things. But if we use the notation of a plus sign for the operation, then we're going to consistently use the 0 symbol for the group identity, and similarly the minus sign for the inverse of a group element. Okay, returning back to the point of this right now, the program here is to state more professionally, at least a little bit more professionally, what these properties are. So identity. right? What is identity? It is the property that there exists some group element such that for all other group elements, this equation is satisfied. And when this equation is satisfied, we say that G is the identity element, and we write it as the numeral 1 when we're working in an abstract group. Okay, similarly for inverses, what does it mean to have inverses? It means that for all group elements G, there exists an H corresponding to G, such that GH equals HG equals 1, right? In this situation, the element H which corresponds to G is written as G inverse in an abstract group or in a multiplicative group. Okay. Note that officially a group is a pair. It is a set together with an operation. Informally, we say that G is the group with operation star. If we must speak about G explicitly as a set separate from the group, we will call it the underlying set of the group. Further, because the group operation is associative, parentheses don't matter, and therefore most of the time we don't write them at all. So for instance, we will happily write GHI without concern for whether this means parentheses on one pair or the other. And we'll cap this all off with a brief conversation about order. The order of the group, G comma asterisk, means the size of G. That's slightly informal. More formally, what we really mean is the cardinality of G, the underlying set. For instance, the order of the integers mod n when taken under addition is n, because every element is there. If it were the group of units under multiplication, we wouldn't have all those elements. Anyway, for the, right, so that's for the additive group of integers mod n. And the order of the integers is aleph naught or aleph null, indicating a countable cardinality.